Okay, so today we're going to talk about the properties of rhombuses, rectangles, and squares. Okay, so if you look at your sheet in front of you, we're going to talk about the different characteristics that we have for each one of these objects. So if you look at the first one, it says a blank is a parallelogram with four congruent sides. So what is a parallelogram with four congruent sides? That's going to be a rhombus. Good. Okay, then the next one we have is a blank is a parallelogram with four right angles. So which one is a parallelogram with four right angles? A rectangle. So we'll put rectangle right here. And then the following one, or the third example, is a blank is a parallelogram that has both four congruent sides and four right angles. So what is that one? That one is a square. Okay, all right. So let's look at problem one and let's determine if we have a parallelogram, if we have a square, a rhombus, or a rectangle. So we say ABCD is a rhombus, a rectangle, or a square, and explain. So we're looking at the picture here and it says, what do we know about this picture? What can we see? Okay, are all the sides congruent? No, they're not. Okay. Do we have right angles? Yes, we do. So if we have right angles and all the sides are not congruent, or at least we can't prove that they are congruent, then what do we have? We have a rectangle. So ABCD is a rectangle. Can you prove that these are congruent? Well, this is the object we're talking about right here. Does that look like? Yeah, I'm pretty sure that this one right here is what they were talking about because of the A, B. Yeah. And so that one is a rectangle. Good question. All right, so now we're looking at EFGH. Okay, so EFGH. So where do we have EFGH? Which one is EFGH? Yep, see it right here? Can you see it? Yeah? Okay, we know that this side is congruent to this side, right? What do we know about parallelograms? What do we know about the opposite sides of parallelograms? They're congruent. So if this side is congruent, then this side, right? And if this side is congruent, then what do we know about this one? It's congruent, okay? So that does give us four congruent sides, right? Okay, so if it has four congruent sides, it's either going to be a rhombus or a square. Okay, now looking at this, do we have right angles? No, it does not look like we have right angles. So what would it be? A rhombus, okay? Very good. Okay. All right, so now let's look at 7 and 8. I'll pause for just a minute so that you can fill in 7 and 8, and then we'll check our answers. Okay, so what you probably found as you worked them out was that your rectangle is number 7 because you have four 90-degree angles, but you do not have four congruent sides. Then when you look at number 8, you notice that you did have four congruent sides, but you did not have right angles. So that would give us a rhombus. Okay. The next two theorems that we need to talk about have to do with the diagonals. If parallelogram ABCD is a rhombus, then the diagonals that it form 90-degree angles such as this. Do you notice that AC is perpendicular to BD? The next theorem that we notice is that if ABCD is a rhombus, then we create these congruent angles. So when we create, or when we draw diagonal AC and diagonal BD, we create congruent angles here. 1 and 2 are congruent, 3 and 4 are congruent, 7 and 8 are congruent, and 5 and 6 are congruent. So not only are the diagonals perpendicular lines, they are also what? Angle Bisectors. Very good. So we would say that the diagonals are perpendicular and they are what? Angle bisectors. Very good. Angle bisectors and perpendicular. And which parallelogram is this true for? The rhombus. The rhombus. Okay, so let's look at problem 2 and see how we could use this information to our benefit. You notice that we again have diagonals AC and BD, and it asks us to find these particular angles, okay? 1, 2, 3, and 4. How could we find these angles? What do I know about angle 1? What does angle 1 have to be? Angle 1 has to be 90 degrees because the diagonals are, remember, perpendicular. So angle 1 does have to be 90 degrees. Now, if you work your way around this figure, you would notice that if angle 1 is 90 degrees, this one is 90, 90, and 90, right? If we look at B is 58 and this angle in the center is 90, then we have 90 plus 58 would give us what? 148. Therefore, what is this angle right here at vertex A going to measure? We'd say 180 minus 148 would give us what? 32 degrees. Very good. Because this diagonal is also an angle bisector, then the measure of angle 4 also has to be what? 32 degrees. 1, we've already told you or already stated was 90 degrees, right? So 90 plus 32 gives us what? 122. And if we say 180 minus 122, what will we get? 58. So angle 3 would measure what? 58. And again, because the diagonal is an angle bisector, angle 2 is also going to measure what? 58 degrees. Are there any question on how we did that? Good. I'll pause for just a second while you can figure out the angles 1, 2, 3, and 4 for rhombus PQRS. What we remember is that opposite angles of a parallelogram are congruent. Therefore, angle S is also going to measure 104. Then, if we use some of our parallel lines and alternate interior angle reasoning, we could say that 1 is going to be congruent to 4 and that 3 is going to be congruent to 2 based on alternate interior angles, right? Then we just decided or just discussed how the diagonal PR is an angle bisector. So that means that 1 is also congruent to 2. Therefore, what we end up with is 1 is congruent to 2, 2 is congruent to 3, and 3 is congruent to 4. Therefore, if we subtract 104 from 180, we get 76. 76 is the measure of angle 1 plus angle 2 as well as angle 3 plus angle 4. If we divide that measure by 2, we will find that each of the angles 1, 2, 3, and 4 all measure 38 degrees. Are there any questions? Okay. For your classwork / homework or practice for this section, you will do 9 through 14. I'll pause for just a second so you can complete 9 through 14 from section 6.4. Okay, and so the next theorem we're going to discuss is the rectangle. So ABCD is a rectangle. If we draw diagonals from A to C and from B to D, we will find out that the diagonals are congruent. Okay, so if these diagonals are congruent, how can we find the length of each diagonal? Okay, so let's look at problem 3. If we look at problem 3, we have SF is equal to 2x plus 15 and RB is equal to 5x minus 12. Well, we just discussed how both diagonals are congruent, so I would say, SF equals what? RB. So then I will substitute 2x plus 15 for 5x minus 12, and then I will solve for x. Okay, and we'll get 3x, and then what's 12 plus 15? 27, so x equals 9. Okay, now notice that the question did not ask you what the value for 9 is. What did it actually ask you? The length of the diagonal. So I will then have to substitute 9 into one of the two expressions to find out what the actual length is. So I'll say 2 times 9 plus 15. 2 times 9 will give me 18, and 18 plus 15 will give me what? Will give me 33. Very good. Okay, now I'll pause for just a second while you guys find the length of the diagonals MO and LN. Okay, so if you set them equal to each other, you will see that because diagonals of a rectangle are congruent, LN is equal to MO. If we substitute the expressions given to us in the problem, then we will find out that x equals 15, and if we plug 15 back in, we'll find out that the length of each one is going to be 43. Now we weren't given any units for that one, so we can just leave it as 43, or if necessary, we can say it's 43 what? U for units. The practice problems for this section are going to be 18 through 23, which are also found in 6.4. So I'll pause for a second and you can go ahead and complete 18 through 23. Okay, now that you have now that you've taken all the practice problems and the notes for this section, continue to practice the practice problems and then use this document here to check your answers.